today I want to run you through name matching solution. We are trying to match insured names to a reference list. That reference list is the capital IQ list of companies. Generally, what this is trying to do is, well, what it's doing is matching insured names to the reference list. But how is it going about it, and how is it able to do that in a time frame that's, for want of a better word, tractable? When I mean tractable, I mean doable in a reasonable length of time. Or well, the key transactional parts that are doable in a reasonable length of time. So we were allotted like half an hour, but what will be a key diagram that I'll wave in front of you now is kind of the flow of the documents that make up the process. It shows what everything's doing and what documents are involved in the solution. It's a two-stage process. The first stage is importing your company list and formatting that and processing that so it's usable as a source for your AVM in the step 2. What this also does is create the word frequency table. The word frequency table is very important because this drives a lot of the structure around the name matching, right? So effectively the general theme of the name matching is that you can't just do an AVM on your closest match, because certain words should have more priority in that. So when I've got Microsoft Corporation is a very common word, so we kind of, it's not really relevant to the name matching exercise, but Microsoft is very relevant. And we bring in that sort of thinking, which is a fairly standard NLP thought process. It's called term frequency, and the concept that, you know, scarcer words are going to be more significant in your name matching. And how do we incorporate that? And we incorporate that by extracting the most unique word from each entry, and we use that as context columns. So in this demonstration, I'll refer to word A and word B. And word A and word B represent the most and the second most unique word in either an insured name or a company name. So for example, in, as I say, Microsoft Corporation, the most unique word would be Microsoft, and because there's only 2 words, corporation would be the second most unique word. But generally it enables you to target like the actual corporate identifier in each of your names.
So is that the word frequency table is based on the relative to the spreadsheet?
It's relative to your reference company list.
Gotcha.
And the word frequency table is just a 2-column table. So so it's word and number of times that word appears. And that's generally the process of this step 1. This step 1, this import company list pipeline, I'll run through it in more detail, but this is the one that you do when you get an update of your company list. So how frequently would you do this? Maybe once a month, maybe once a quarter. You do it once for your whole organization, because you only need to really update your company list and your word frequency table on any new company list update. So that's what step 1 doing is it's converting your raw list into your process list, and also creates the word frequency table. And I'll talk about what that process list looks like later on. Step 2 is doing the name matching. So we take the risk data and we take the header file, and we take the word frequency table, and we take the company list. Putting all that together, what do we get on the output? So the output is the data only, and this is kind of two outputs that we have with the data. So we have the data only that matches the header file. So where we've got the headers, this input here, this headers input here, that's effectively dictating to us what our output's going to look like for the data only. For this example, that we're using this to be a demonstration to do an API call. So I've got this dark gray box here in this diagram that does the API call and will get us some enriched data. But basically what the key takeaway is here, that the headers is just a blank file, a zero length table with header information that's going to dictate to us what our output looks like. Because we're only using this as a demonstration to do to showcase APIs, this is a very simple file. So it's a very simple header structure. But that could be like the predicate header file, or it could be the Arium header file, and effectively, or the SOMPO SQL table that they need out of it, and then we would recreate that table with the completed data in this output data only section. Supplementary to that, we have the output data with analysis, and this shows us all of the metrics that are created through the name matching process. This is for debugging, checking, confirming, but most of all, it enables us to do some reporting and use the reports to target report on how good our name matching is doing, give us some visibility around our name matching, look for any close matches, look for any close near misses, any near misses with high exposures, and look where our chunky matches have come from. So it's going to enable us to target, the manual work in either remapping or mapping stuff. Each business area, so hypothetically, and this is a bit of a stretch to go into sort of individual company setups, but I think it's quite feasible to think that this step 2 section, you would probably need it once per business area. So for example, one of our clients, SOMPO, they would have one of these, all of this step 2 shaded area. They would have one for trade credit, one for professional lines, one for every business area. That's why we've kind of got that concertina section of multiple layers of this, and that brings with it a focus on maintenance. So one of the things that this whole structure is based around is reducing maintenance and making maintenance tasks like add a new business area as easy as possible. So this is supposed to be, that lifting the bonnet of this is supposed to be hopefully quite easy. What else can I say about this flow? It might be worth jumping around and go into the name matching layers that happen in this, because this drives a lot of the processing that's required. So with name matching, I can't just go in when I'm a name matching to a 7 million row data set, which is what the Capital IQ data set is. I can't jump in just AVM on 7 million rows of information, because it's going to take you days, literally, to run through, and also it's going to be ineffective. So where you have ABC Corporation, that will match with high positivity to CDE Corporation, despite the fact they're completely different entities. So we need to do lots of pre-processing required, to eliminate things that make it to AVM, because AVM is a fairly time-consuming exercise. But also there are some real quick wins in your name matching that you can get away with, that our review says this is really high accuracy, and we don't need to actually AVM these columns. And these 6 steps are kind of the steps that we go through. So the first thing is do we have an exact name match? And if I sort of, these are kind of gates here. So if I get an exact match, I'll take that exact match and I won't need to do any subsequent steps. So is there an exact match in my reference data set? If there is, good, I'll take that. If not, then I'll move on to the next layer. If I trim and upper the names, and this is on both sides. So if I've got I create a trim and upper version on my reference side, and I create a trim and upper version on my input side. Is there a match there? Great, move on. If not, move on to the next lane. Then I'll create what's called a fuzzified version of the name. And I'll go into the fuzzified steps in a second. But this creates a soft version of the name. It irons out any foreign characters. It irons out non-alphanumeric characters. And that's not only used as the AVM source and for the word count source, but we also match on that in this sort of raw basis. Again, if you find that fuzzified match on both sides, then we accept that match and we move on. Then things start to get a bit technical. So where I've got word A and word B are the same. And this will then say, well, if your first and second most unique word in your input data, if there's a value in your reference data that have the same first and second most unique word, then we'll assume that to be a match, and we'll take that match. Next layer is where word A is unique in the word frequency table. So this is where I've got Diageo. If it doesn't, but assuming Diageo, the word Diageo only appears in one entry in my reference list, then if the word Diageo appears anywhere in my input list, then it will take that Diageo record in the reference list. And these are kind of the start of my automatic acceptances. And then after that, we get to AVM. And I AVM using the first letter of the entry and the word A as context columns. This is with not something that I'm doing to make it a more effective process. This is these context columns are added purely to make it quick. And so AVM will return us an answer. And then we kind of have started to introduce the concept of some automatic versus manual acceptances. And this is a bit of a niche concept, but basically without any automatic AVM acceptances, we're entirely reliant on you going into your manual mapping report and going yay or nay on your AVM result. But what I noticed, and this is I think actually specific in one of the use cases that I had, one of the sample data that I had, was that there were some patterns that you could sort of include as like an automatic AVM acceptance. Here is where you could also put an auto acceptance that if the match strength is over 90%, then I'll accept that to be correct as well. It's a huge problem, or unrecognized problem with name matching is when you see all of these entries. I might have two entries, and I do have some entries in the capital IQ that have two exact names, or two entries with the same exact name, and that's a problem because I don't know which one to take, right? And that problem is kind of exacerbated as you go down this ladder of matching types. So when I trim and upper the reference name, I'm also inviting in more. Like it's a for want of a better word, fuzzier version of the name, and that's going to bring in more scope for there to be multiple entries, multiple IDs with the same trim and upper version of the name. And more, likewise when I get to the fuzzified version. So you'll see a lot of stages are dedicated purely to selecting one and one only of these entries. Currently, that process is just to pick the first one in the list. If and again, leaving scope out to some more more interesting interpretations of how you could do that. What I do have is a validation that says, well, I've selected you ID 12345, but realized that this could be one of, I've picked one ID 12345. It could be one of 7, for example, IDs that are returned by this rule set. We've just picked the first one. So I have the exact version, I have the trim and upper version, I have the fuzzified version. What is the fuzzified version? Well, the fuzzification process of the string goes through a number of stages. So first of all, I capitalize it and I remove any leading or trailing space or mid white space, which is the same as the trim upper version of the string. But then I took out some. I took out the foreign, so accented characters, and also I've introduced the ability to put in some other substitutions. So one of the ones I put in is limited, shortens to LTD in every instance. Also, the next layer was to strip out alphanumerics. And this was largely to deal with the fact that some people would have alphanumerics in there, some wouldn't. And if you do it on both sides, like the input and the reference, it has a benign influence on the erroneous matches, but it brings in a lot of entries where systems wouldn't record alphanumeric characters correctly. So some people would put R-D, some people would put R.D, some people would put R and D. And the last step, which is really cool for the regex fans amongst us, full disclosure, I absolutely Stack Overflowed this, but I was able to find a regex that took out consecutive initials and turned them into one word. So that was super impactful for people that put S.A.R.L, and then that shortens to SARL, and just say normalizes it on both sides, because that was a really common mistyping or causing of confusion. So darting around a bit slightly, just when I talk about fuzzification, it's about simplifying, because a better word, the entry, and we do that on both sides. We do that on the reference list and we do that on the input list. And if I talk about AVM layers, or sorry, name matching layers or types, these are the types that we go through, and these are kind of steps, sequential that we. But if you see the platform now, I will show you what this first stage is doing. So this is import company list, and I might need to zoom in here. Basically, this pipeline represents that leftmost gray area on that global document flow.
Hi, Tom here. We've done a whole load of optimization on this pipeline, which generates the word frequency table and the company list. We've made it faster to run, and I want to show you in detail what we're doing. To help with that, I've got a sort of a run through of what the data looks like at every stage in the pipeline. I'll just recap what this pipeline's doing. So we're inputting a list of companies, company IDs from capital IQ. And what we're trying to get to is a company reference list, which is the same list of company names and company ID with what we call a fuzzified company name, and word A and word B. Word A is, as Dan was saying earlier, that's the most unique word, and word B is the second most unique word. So we analyze the whole data set and we say, okay, corporation, that word occurs a lot, that's not very unique. But Exxon, that occurs only once in this data set, so that's very unique. So that's what this pipeline is trying to achieve, generating these two lists. So I'm going to go through, stage by stage, exactly what happens to the data. So first up, we get our raw input data. And the first stage is to fuzzify it. Let's see how we do that. So we do the regular stuff about detecting headers, adding row numbers, and then we do a bit of trim and uppercase, and then we've got some pretty wild calculations to convert those company names to ASCII characters. So that means removing all accented characters and replacing them with a non-accented version. Then stripping out stuff like colons or non-alphanumeric characters. Using a regex, combining initials, and then this is the really cool bit. Split string into individual words. Lots of calculations there. Let's see what they're doing. So we've fuzzified the list. We're going to hide that company ID column for now. So this stage is splitting Acme Corporation into individual words and then counting the number of words. So Acme Corporation 2 words, ExxonMobil Corporation 3 words. Let's see how we do that. So we create a column called remaining words. Then we create a column called word 1. And in that column, we have an if statement. And what that if statement is doing is saying, identify strings with spaces in them using our find function. Then, using the left function and find function again, if they do have spaces, return the first word, and we do that by locating the first space, stepping back one character, and taking everything left of that. So that's what the left function does. And then, so identify strings with spaces. If they do have spaces, return the first word, and if they don't have spaces, then just return the original string. So that's going to give you the first word. Then we overwrite our remaining words column, and we do the same in reverse, essentially using the right function and the length function to say, take the characters minus the first word or return a blank. And this just repeats those same two expressions all the way down, and that will split out the words into columns like this, and we go all the way up to 12 words. We've got plenty of documentation. If you're not familiar with functions like left or find, it's all in our help center here. Plenty of examples. So we go all the way down, 12 words, and then finally we have a calculation saying number of words. This is just a big nested if statement that says, say, if the word to column is blank, then the number of words must be 1. If the word 3 column is blank, then the number of words must be 2. And it goes all the way down, and that then populates this column. Okay. So that's the first stage. We've got our cleansed data, just using a union there to rename the output to make it easier to follow through the pipeline. Then we run the process to create one row per word. And we do this with a join to a lookup table. Now this lookup table looks like this. So this column is called number of duplications. This column is called word position in duplication. Let's jump back to the example. Here's a simple version of that lookup table. So row 1, number of duplications 1, word position 1, number of duplications 2, and so the word position can either be 1 or 2, and so on. So when we then join on the main table's number of words column, you can see it's going to do this. It's going to create a kind of one-to-many join. So that's going to give us the word position 1 or 2, 1 or 2, 1 or 2 or 3. We're reading in this last column here. Let's jump back to the pipeline. So now we need to take those words, move them into a single column. Do that with another calculation. And that calculation is just saying if word position is word 1, take word 1. If word position is word 2, take word 2. If word position is word 3, take word 3. So now we've got a column for all the words. Next, we need to count them, count their frequency. So, first thing we do, very simple, create a column to put a counter in. That's that sort of counter column. And we sum it all up with an aggregate. So that's counted that there are 4 instances of corporation, 4 instances of ink, and 1 instance of all the other words. Here's the aggregate stage to do that. Pretty simple. Take the column word, set that as a dimension. I'm going to call the output unique word, and then just sum up the word frequency. Call that unique word frequency. So that's what we get, and that's one of our pipeline outputs. That's our word frequency table. Okay, on to the next bit. Next step is to join that word frequency table back onto the company list. Just simple join using the word and unique word columns. And then we'll get into the real meat of this, which is the frequency calculations. So the frequency calculations say, okay, what's word 1? How frequently does that occur within the capital IQ dataset? What's word 2? How frequently does that occur? What's word 3? How frequently does that occur? And we keep our word position table there, and our unique word and unique word frequency. Let's see how we do that. So first we've got a kind of a control for long strings. We can just throw in a warning exceeds word count. Then we have a series of simple if statements which just populate the word frequency from the table that we've just joined in. Then we squish it all back up again with an aggregate. We bring back in the company name, the raw company name, bring back in the company ID. We also bring back in these columns, original row, company name that's been trimmed, and the fuzzified. Well, we already have the fuzzified company name in here. So these two I've omitted from the simple example, but we also use them for the matching process. And then in each one of these aggregations, we say take the so we say in the word 1 column, take the value based on the maximum value in the word 1 frequency column. So take the most frequent value. And then in the word frequency column, we just take the max value. So that's going to roll that all up. That's what that looks like. So we've got our word 1 frequency, word 2 frequency, etc. We've removed a lot of these blanks using that aggregate. So the next stage is to calculate word A and word B. As we said already, first and second most unique words. Let's see how we do that. Whole series of calculates We actually have to split this across 2 calculate operations, because I think the maximum number of calculations you can have in a single operation is 50. So we do word 1 to 6. And all these are doing is saying, is this word frequency better than my existing word B frequency? If yes, shift it into column A, and if not, shift it into B. Do that 12 times. And that's how we generate word A, word B frequency. And then the final stage is just to clean up that table. Strip out any columns we don't need, and let's see how we do that. We do a bit of deduplication. So there might be multiple entries for a company name, potentially with different company IDs within the Capital IQ dataset. This helps us deal with that. Just doing a bunch of aggregations. And then we join those deduplicated aggregated tables back into the main one, then clean it all up with map column headers at the end. Then stick in a couple of unions just to rename those output files to make them easier to access. Then we've got our nice output data with our fuzzified name, our word A frequency, our word B frequency, ready for running an auto value map process, and the word frequency table, which we also need for running that process. Okay, going to hand it back over to Dan.
So this is the word frequency table, as you might expect. So there are, in my 7 million row data set, there are 1.9 million unique words in there. I can tell that here because there are 1.9 million unique words, and this is how many times they appear. My company list is here. All I've got now are these fields, which are the name, the ID, the original row, which we always wanted, and now I've got the various versions that we're going to use for the name matching. So I've got, this is the trim upper, this is the fuzzified version, this is the most unique word, this is the second most unique word, and this is the frequencies of those 2 words. And then these are how many times those values appear. So 4C Ventures, just got that correct. Yep. So I know that 4C Ventures in its raw format appears twice in my list, right? So and this is filtering a 7 million row data set, so apologies, this is pretty bad telly, but I want to show what this looks like, and hopefully that it works. It will come up with 2 entries where the company name equals 4C Ventures, but only one of them has an entry of 1. Here we go. Perfect. So there's 2 entries for 4C Ventures. So even without any processing, there are 2 entries, one with this ID number, one with this ID number. And what I'm doing is saying that I'm letting us know that there's 2 entries in this column, but I've got an is first column that says only take this one. So when you join, you just have 1 as a number, and that knows that when I'm joining on the raw name, it will always only ever pick the first raw name to return. So that's building the reference table, and this is again when I call this company list, aka the reference table, you know, various other things you can call it, but this is my 7 million row reference table that we're going to AVM to. And because we've added all of these fields, we're able to AVM to it with accuracy, and we can put in those layers beforehand to stop me actually going to AVM. So we're going to go back to the other integrate, and the other integrate is actually really similar. sorry, the other pipeline is really similar, because I'm not sorry, I've done this before. So I'm kind of doing things all like on the other side. So I'm doing all of this processing for my reference side, but also need to do the same for my input side. So what does that look like? It's a slightly different intro. So instead of me using formulas to show me what data I need, I am using map column headers. And that's because my input might change. So if I'm mapping all of this to predicate information, I would have predicate header file as my thing, and I would need to map everything except from company name and except from company ID in this stage here. But similar concept about using those calculate columns to point to the correct columns. What else? You see here, we've got really similar stage names and stage types. So this is where we've got all of the input risk data. This is in the header file where we add those, do the fuzzification, do the raw and the upper, all that sort of stuff. Where you see hashtags is where so the hashtags are in here are either IRD or HDR. Hashtag IRD means you may need to change this stage or this operation if the input risk data changes, the format of the input risk data. If the format doesn't change, you won't need to change it. But if you have an extra column or the columns are spelled differently, then those hashtags effectively highlight where you need to head to change. So it's a real finite list of areas that you need to go into the platform to remap or rejig if your input data changes. And it's the same with HDR. So HDR are only fields that you would need to change. So for example, exposure, I only need to change this column if my header file, the column for exposure, my header file change. And I try and join on all of these entries here first. So if I've got a raw entry in my reference data set, if my trim and upper version appears in my reference data set, where they be, where they find, they all appear, and I don't need to AVM. So I calculate whether any of those appear in this section here, and if not, then I've got to AVM it. I create dedicated input values for my AVM because just to avoid, so I can have like a do not map where we've seen these values. And this is the AVM. It's quite an arbitrary value that I've set as the minimum. I think it's 70 just for time. I can't see much value in going lower than that. I want to rush through this because there is one exhibit that's going to be really useful for all of this. I guess this is quite interesting here at the bottom. So this is where I've got my AVM result, and here is where I'm able to say, well, if it's a perfect leftmost subset of my answer, then assume it to be correct. Don't bother requiring a manual override. But this is where you put other automatic acceptance criteria in. So, for example, if the match strength was over 95%, assume it to be the same. There is a slight flaw in this process in that you can't really unmap or unwind any of these. So if you did have a trim upper version, it will accept it all. Like a trim upper version in your reference data and your input data, it will always accept that. There's no way to unwind that. You could change that if you want by putting an AVM stage at the top here to sort of bypass your trimming. But there's various other costs to that approach. So clean up, convert it to the output, and then we create the two outputs here. So one is the output with analysis that we use for the next juicy thing that I'm going to show you, which is the report, and then we just have the output, which will reflect our column structure that we've added as the header file. So I've rushed through this pipeline because it's so similar to the reference pipeline, because we're doing things the same on both sides. Hopefully, when I have a document created that sort of steps through this in a bit more detail, you might be able to go through that at your own pace and make this a bit more effective. But one last thing I do really want to show you, and this is kind of one of the supplementary benefits of making this a simpler exercise. And the beauty of simplification is that it gives you a bit more headspace to do things like this analyze tab. And this analyze is pretty cool. So because we just got caught up so much in struggling with the pipeline that we didn't sort of have effectively the brain space to say, well, let's create a dashboard to see what we're doing. And this dashboard is pretty cool because we say, right, well, these stats are pretty unfair to the process. They're normally a lot higher than this. But it's saying each of my mappings, I've mapped 57% of them by row count, also 57% by exposure, so the other way around. These exposures are arbitrary numbers, just created from some random number generators. But then to jump over to this side, say, well, of those values that I have got a match result from, where have they come from? So did it match on the raw entry? 26% did, so that was a like perfect existing entry we didn't need to do anything to. Then on the next layer with that trim upper version, we've got 8% an exact match and 21% an exact match. Where the word A and B was the same, we've got a 40% match. That's been impactful. Where the word A was unique in the reference data, it's 3%. And then AVM, we've manually mapped 873 million pounds worth of exposure, but that auto acceptance has picked up 3 million. So this gives us really good stats around how much we've mapped and through what tier of the mapping process we've mapped it at. And this is how am I going to get my match number up? So 57% now. I don't want to waste my time going through these alphabetically. I don't want to waste my time necessarily going through even the closest matches, because you know that I still could be picking up the small fry. But this allows me to say, this table here says, right, I haven't got an entry for any of these entries, but it's mapped by the exposure. So I can now go into my mapping report and say, well, filter on kinetic, find out what kinetic should be mapped to, and go through all of these sequentially. So I'm using my time, my manual mapping time, in the most effective way. In the design phase of things, where I'm thinking, you sure we don't want to map any of these, right? These are fairly obvious, although protégé energy 3, should it be protégé energy 2? That's interesting. But you know, just give you a view, these are the near misses that we haven't accepted. So could we accept these? And then finally, this would be part of your sort of audit. You just say that these are the things that we've matched to. And these are just things that you could wave in front as an appendix, just to say, you know, we haven't guessed these. These are all what we've mapped to, where you've mapped them from, and just to make sure that we aren't mapping anything that's really impactful, i.e., our highest exposures, to inaccurate mappings.
How are those near misses defined? You might have said, but I missed it.
So these are ranked by match strength. So when we AVM something, it returns us the guess and how strong was that guess. But if we haven't accepted that guess, then it still keeps the sort of the match strength here. So these are all ranked by match strength. And these are, then the last sheet here is what have I manually mapped. So if I went in and went to my mapping report, did some mappings, rerun it, that would appear in here. But this should map, if I go to, this would be a big test.
So how were the manual ones picked out?
So these are just the manual things that I've remapped or approved.
Yeah, how did you fillet them out from the rest of them?
Because the match strength is 100.
Yeah. And do we only get match strength 100 with manuals, or?
Yes.
Yeah. Okay.
Yes. Because if, interesting point, Tom, normally you would get match strength hundreds for exact matches, but the fuzzy match would have picked it up anyway. We've done a fuzzy join earlier in the process, so
yeah.
And it, we do have that problem where we have inexacts, where the same words in a different order, the first and last word are the same. They have the same match strength, so they have 100% similarity, even though they're different. There you go. I've just got 3 entries here, and that matches. There's my 3 entries there.